Hello and welcome back to another video about the computer networks. In this section we were talking about the physical layer. We have spoken about many things in this physical layer, about the topologies, about the data flow, about the connection types and sizes. And in this part we're going to talk about the transmission medium. The transmission medium, I have segmented this to be as different part because usually this is the harder part, and this is the where experts usually are. It is segmented firstly to have the following structure, that the transmission media can be one of two parts, or one of two forms. Can be guided or can be unguided. Okay, so it can be guided or unguided. The unguided one is usually called as we're going to talk about the free space, or we're not going to talk really about free space too much, because we are going to talk about the guided first. The guided one is the twisted pair cable, which is twisted pair cable, and there is also the coaxial, and there is the fiber optics cables. So the twisted pair cable, as we know, is the one in our homes and the one in our Ethernet, having the name of UTP. So UTP, unshielded twisted pair. The cable itself is of two lines. These two lines go around each other. Why do they go around each other? To remove the electromagnetic interactions, or like if the two lines were next to each other, each line makes electromagnetic field. If these of two fields interact with each other, they make noise. We don't want to remove this. We want to remove this noise. We don't want noise. So in order to remove this noise, they have twisted these pairs and found out that this is better actually for the cable. Coaxial cables are longer distance, bigger, sending for the radio waves. Especially, they don't really they have a special structure of a core. This core being the inner layer, and the outer layer being like the positive. It's like the positive or negative, and the outer layer, after they are being separated by a shield or a sheath here, connects the other part of the connection. So let's say this is the positive and this is the negative. So this is the connection of the coaxial cable. It exists for instance, in things that need guidance. It needs guidance for the electromagnetic wave itself, not like the twisted pair. Guides positive or negative. It just provides, electricity. So this is UTP. It provides electricity, but here it provides waves. So this wave, like radio waves, which happens to support our TVs. Then we need coaxial cables. Then for the best one of these, we can't say it's the best because it's the most expensive, and it doesn't really bend that much. Is the fiber optics. The fiber optics have two types. It can be either single mode or can be multi-mode. The single mode usually has the connection from A to B on a linear path, like that. It passes by the core, and it has lower bandwidth. It doesn't pass bandwidth. It doesn't pass too many lines, but it has very bigger range. It can go kilometers, sometimes up to 100 kilometers, or like crazy ranges, like city ranges. So single mode is usually between cities. But multi-mode is the one that we find in our backbones, in our, I'm not in our backbones I mean, but our city backbones. This one passes multiple layers of signals and multiple waves, multiple of other waves or lasers are connected, and they pass through this core and send the message we want. Being the multi-mode, it usually has lower distance than the single mode, but higher bandwidth. It can carry more than a single wave. How we can find out whether our signal was our cable was a single mode or a multi-mode? This is usually yellow color, and this is usually orange. The multi-mode is usually orange. You will find if engineers are installing of optical fibers around your house, it will be an orange color, because this is usually the multi-mode. This is the one you are not using it for long range transmissions or high speed transmissions. It's more for multiple fast transmissions using optical fibers. There's also much more to talk about in the optical fibers, and how is the laser being transmitted, and what type of laser, and how was it transmitted, and why was it even the best case for a fast speed, and so on, and the mediums, and so on. But for the simplicity of this course, the fast fiber optics is one of the fastest transmission ways we have, and one of the most secure, especially considering the fact that it doesn't get affected by noise, not affected by electromagnetic mediums. So you can just pass a fiber optic cable next to a power cable and nothing will ever be a problem for us. The next part, which is usually the hard part, well, before the hard part, we have the wireless medium itself. We haven't talked about the unguided or the wireless. So the wireless is one of three ways. It can be radio wave, it can be microwave, or it can be infrared. So infrared is the one in our remote controls. The remote controls we have at home is infrared. They have that little LED in the end. This LED in the end is transmitting infrared to our receivers at homes. At our home in the TVs. We can see this infrared. You can't see it by your eye, but you can see it through a camera. You can have a mobile camera or a phone camera and try to look at this remote control while clicking on buttons. You will find that it flickers color, usually blue color. That means that the camera of our mobile phones can see infrared, but we can't. So it translates this infrared to a visible colors to our eyes, and the visible spectrum. And there is the radio wave and the microwave. Radio wave is the general here. Microwave is a subset of the radio wave. It's a spectrum of gigahertz of hertz, ranging from short wavelength here, I mean high wavelength here in the radio wave, going shorter till becoming microwave. Microwave, the frequency goes higher. So a radio wave with a high wavelength means that it can go high distances. But it doesn't. But in the microwave, since the frequency is higher, it can have more data. So the data bit or the bit rate is higher here in the microwave, but the distances in the radio wave is higher. Something else so that means that the frequency here is higher, which means there is higher noise. The radio wave here is the wavelength is higher. Both are being operated in our communication and the wireless communication. The microwave is actually very close to us in our homes. It's not like the microwave ovens. Like the microwave ovens is a special use of the microwave for heating, but this actual microwave is in surprisingly in our Wi-Fi routers. In our wireless routers, for the ones from 24 gigahertz to there's 5 gigahertz also, are also actually microwave routers. Radio waves, on the other hand, are used in TVs or in transmission towers, like the transmission towers in the cities actually transmit radio waves. So they have transmission of radio waves because these radio waves can go on long distances. Yeah, but it doesn't need really high data or bit rate. You don't really transmit something that heavy. You're not sending files or something. So that all was about the wireless transmission. So next part is the hard part. Okay, so this was all introductory to the what was going to talk about. We are going to talk about now the switching. And now, before we're gonna talk about the switching and the switching types, we are supposed to know the multiplexing itself, or the division multiplexing. So the switching, I think that it's gonna be on the next video, but for now we're gonna talk about the multiplexing mode. So we have things like CDMA, we have FDMA, we have TDMA, and there is also FDMA or FDMA, yeah. So what are these and what do they present? So the FDMA, which do you know something like called the I think all of us knows the AM FM radio waves, yeah, AM FM radios. So AM and FM are amplitude and frequency moderated, and there is also PM, phase moderated. So these occur under something called the 1G. When the telephony or the cellular communication occurred, the first generation was called the 1G. It used something called the FDMA. So it's something called the frequency division multiplexing. So what happens is, let's imagine there is a multiplexer, and what does a multiplexer do? It gets multiple inputs. So let's say it's device 1 and device 2 and device 3. All of these are shared and goes to another multiplexer, demultiplexer here I mean, and gets back to be received on device 4 and device 5 and device 6 representatively. So the wave here is sent over channels. So the channel 1, let's say this is channel 1, this is channel 1 here. Then there is there's a bandwidth, there's a guide band, or there's a guard band between them. Then there is channel 2 and there is then channel 3. So each of these messages are sent on a different frequency. So different frequency 1 and frequency 2 and frequency 3 are different. So in order to send each message on a different frequency, to not make the messages get into each other, yeah, and like fall into each other. So the first message is sent on frequency, let's say frequency 1, and the second one is sent on frequency 2. So there will be less collisions, yeah. Between those two frequencies there will be something called the guard frequency or guard band, yeah, guard band. So a message is sent in FDMA as in form of like say this is message, and this is the message 1 F1, then there happens to be a guard band here, then the F2, yeah. All of these are sent on different channels. It's the channels. So there is channel 1, channel 2, channel 3, all on the same link, all fall under the same link, yeah. So this is the link with different channels. Okay, so this was the first one, which was the FDMA. Then it happens to become the TDMA. This is the one used in the 2G. The message here is divided by time. So instead of using frequency, it uses time and scheduling of time. So packets are sent again on a multiplexer here, and received on a demultiplexer. The messages here are, let's say this is 1 and 2 and 3. So 1 is going to send multiple packets here, multiple segments, and this is going to send for also, let's say, multiple segments, and this is going to send multiple segments. So let's say name them A and A, and this is let's say A1 and A2, B1 and B2, C1 and C2, and this is going to, on here, is going to receive we want to receive A1 and A2, we want to receive B1 and B2, B1 and B2, and we want to receive C1, C2. So in order to receive these, we are going to do this by time, by schedule. Each portion takes a time delay. It takes the whole bandwidth, but the total link channel capacity, but it segments this to be in order, like schedule, like that. So let's say it's gonna send here like that. It's gonna send A1, then B1, then C1, then gonna send A2, B2, C2. So the thing is, it sends to this, then to this, then to this, then sends back the second packet for this, then this, then this. So this is the TDMA. This is it happens to be better than the FDMA. It's the better generation. It allowed faster transmissions and so on. The third thing, the third multiplexing method is CDMA. CDMA is called division multiplexer. In multiplexing, it uses some code method. It's not that complicated, but it would take a long time. It adds some numbers, then makes XOR and does some addition, and then it receives back the message to be 0, 0, 0 to do checksums. So it's faster and more secure, but it is in the 3G. This is the 3G. This is the what may cause the 3G to occur. But since now 3G is old technology, it's not used that much. It's used in multiple countries, but it's not used as a basis of a new generation like 4G and 5G. Meanwhile, 4G and 5G generations have the what we call as the OFDMA. So the OFDMA had the ability to send over frequency, but here it's something called orthogonal. So it has polarity. It can send the packet and make sure that the unused frequencies can actually have subclasses within it to send full packet size, like to fill up the data. If there is, like, let's say this segment only is filled from the data, no, we want to fill these two, fill also these, fill them. We don't want to leave them unfilled. Instead of the gaps and the bandwidth, which band gaps, which takes place from our bandwidth, we can fill this up using the OFDMA. So this is the third one, which was the OFDMA. It's OFDMA. It's used in the 5G and the 4G. 5G it adds up something also to it to become even for 5G like as strong as now. Starting from the 4G, the internet or the telephony it's telephone or like cellular plus internet. It gets internet speeds and internet connections through the mobile. Like mobile phones has in both mobile internet and mobile communication, telephone and calls. So this was it for this time. I hope this was useful, and in the next part I'm going to talk about the switching within the physical layer. And thank you very much for your time, and I hope you enjoyed this video.